In today's video, we are going to be discussing volume. Firstly, let's understand what volume is. Remember back to 2D shapes when we were asked to calculate the area inside of the shape. The area would refer to the part that I'm coloring in over here. So the area was how much fits inside the shape. For volume, we are once again trying to figure out how much of something can fit inside either of these shapes. So for example, if I wanted to know how much liquid could fit into this cube over here, I would essentially be asking you, what is the volume of this cube? How much can it hold? This is very similar to the calculation we used when trying to find out the area. However, we now have an extra dimension, the height. That is why we refer to these shapes as 3D shapes instead of 2D shapes, as we now have an extra dimension. So, once again, when we were asked to calculate the area of a 2D shape, for example, if I asked you to calculate the area of this square over here, you would know that to calculate this area, you would need to multiply a side by a side. And since all the sides in a square are equal, this is just side times side, which gives us side squared. Similarly, when we're calculating the volume of a cube, we need to multiply each of the different dimensions. So we will need to multiply the side here by, let's say, this side here. But remember, we have a third dimension, which the 2D shape does not have. And because we know that all the sides of a cube are the same, we can say side times side times side. And this gives us side cubed. And this is how we arrived at the formula for the volume of a cube. For question 1, we are asked to find the volume of this cube. So we start out by writing our formula for the volume. And we know that the volume of a cube is equal to the sides cubed. And that will be 2 cubed, and that will give us 8. Now don't forget, you need to include your units, so we will have 8 centimeters. But since we were finding volume, we need to say centimeters cubed. Just like we used to say for area, if we were calculating the area of a square and it was in centimeters, we would say centimeters squared. For volume, we then say cubed instead of squared, because we have 3 dimensions instead of 2. Question number 2, we are once again asked to find the volume of a cube. So we know that the formula is s cubed, and s, we are told, is 8. And we can use a calculator to determine what 8 cubed is, and this should give us 512. Now once again, we were working in centimeters, and we need to remember that since we are trying to find volume, it will be centimeters cubed. For question number 3, we are now dealing with another type of shape. It is no longer a cube, but instead we now have a rectangular prism. So we need to have a look at our formula sheet to find what the formula for the volume of a rectangular prism is. And after looking at our formula sheet, we see that the volume is equal to length times width times height. Next, we are going to need to look at our figure to identify the values we're going to substitute into our formula. So the first value is length. And if we have a look at our rectangular prism, we can see that our length is 6 inches. Next, our width is 3 inches. And lastly, our height will be 4 inches. We can multiply all of these together, and this should give us 72. And once again, remember, we are working with inches, and because we have 3 dimensions, it will be inches cubed. For question 4, we are given this shape over here, and once again asked to find the volume for this shape. Now, some of you might not be able to identify what this shape is, but keep in mind that you will never be asked to to find the volume of a shape for which you do not have the formula of. What they might do would be to give you a shape and you would need to break it up into its components, which you do know. However, this is a shape that you should be able to calculate fairly easily. This is simply a rectangular prism. So we can start off by saying what we already know, and we know that the volume of a rectangular prism is the length times the width times the height. Next, we need to substitute in these values. So we can have a look at our graph, and we can see that the length will be 3 centimeters. The width will be 5 centimeters, and lastly the height is 2 centimeters. This should give us 30 centimeters. And once again, we're working in the third dimension. We were multiplying 3 different dimensions by each other, so this is centimeters cubed. It didn't matter if you chose this to be your length, this to be your width, and this to be your height. You would still arrive at the same answer as long as you are not using the same dimension twice. Question 5, we now have a slightly different shape. This is a triangular prism. As we can see, this is just a triangle which has been extended into the third dimension. If all this talk about different dimensions is confusing you, don't stress too much, as long as you are able to identify that this shape over here is a 3D shape. So, to calculate the volume of this 3D shape, we need to find the formula for the volume of a triangular prism. So, if we have a look at our formula sheet, we can see that the volume is equal to the length times the base times the height, all over 2. Next, we have a look at our figure and we substitute in the appropriate values. The length refers to this over here, so that is 14. Now the base and the height refer to the base and the height of this triangle over here. So if we have a look at the triangle, we see that the base is 12 and the height of this triangle is given to be 8. And we divide all of that by 2. We can then put this into a calculator and get an answer of 672. Now we are dealing in inches and we say cubed because we're dealing in the third dimension. And that is our final answer for question number 5. For question number 6, we are once again given a triangular prism. So to find the volume, we once again need to use the formula length times base times height all over 2. Next, we're going to need to look at the figure to be able to figure out which values we're going to substitute in where. So we can see that this value is our length. So we've got 19. And once again, the base and the height refer to that triangle. So the base of this triangle is 12 and the height is 7, and that is all over 2. Now we can type that into our calculator and we will get 798, and we are working in inches and we cube it since we are working with volume, and that is our final answer for question number 6. For question number 7, we are asked to find the volume of this polygon over here. Now, if we have a look at this shape over here, we can see that this is a trapezoid. Therefore, this polygon that we are dealing with is a trapezoidal prism. Therefore, question 7 is asking us to find the volume of this trapezoidal prism. So to start off, we need to find the formula for the volume of this polygon. So we have a look at our formula sheet and find that it is a plus b times height times length all over 2. Next, we are going to need to substitute in the relevant values from the figure. So both a and b come from the trapezoid itself. And as we know, a is the top line of this trapezoid. So we can substitute that in, and we know that this line is the same length as this line. So that'll be 12. And b is simply the bottom line of this trapezoid. So that is 8. The height in the formula refers to this height inside the trapezoid, so we say times 10. And lastly, the length is simply the length of this polygon, which we are told is 22, and all of that is over 2. Now we can substitute, or rather we can type all of this into a calculator, and we will get that this is equal to 2,200. And remember, it is centimeters cubed. Question 8 once again asks us to find the volume of a trapezoidal prism. So once again, the formula for the volume is a plus b times height times length all over 2. And remember, a and b refer to these top and bottom lengths of this trapezoid. So we can substitute these values into our formula, where a is 8 and b is 14. Our height is simply the height of this trapezoid, which is 4, and our length is the length of the prism, which is 10. Now we put all of that over 2, and we can type that into our calculator, and we will get an answer of 440, and this is once again centimeters cubed. And once again, for question 9, we are asked to find the volume of another type of 3D shape. And as you should be able to see, this 3D shape is called a sphere. To find the volume of this sphere, what we do is we look at our formula sheet and we see that the volume is equal to 4 over 3 times pi times our radius cubed. Now, for a sphere, the only missing value is the radius. Now, if we have a look at our figure, we can see that we have got a line which extends from one side all the way to the other. And as we should know, this is not our radius. This is our diameter. To find a radius, we need to divide the diameter by 2. This is because our diameter is equal to 2 times our radius. Therefore, if we're just looking for radius, we need to divide diameter by 2. So we can see that our diameter is 42. So if we divide that by 2, we get that our radius is 21, and that'll still be centimeters. So we can now substitute this into our formula for volume. So we will keep the 4 over 3 times pi, but now instead of r, we substitute in our value for radius, which is 21, and we keep the cube there. Now we can type this into our calculator, and we should get that this is equal to 1, 2, 3, 4, 8 pi. Now remember, pi is just another number, so this can be simplified even further, but we need to remember that pi is an infinitely long number, right? It's got infinitely many decimals. So our final answer is going to need to be rounded off, and we can round it off to 2 decimal places. So your final answer should be 38,792.39. And remember, we were dealing with centimeters, so this final answer will be in centimeters cubed. Lastly, question 10. We're once again asked to find the volume of a sphere. So we can write in our formula, which we should all know by now, 4 over 3 times pi times radius cubed. Now for this example, they have already given us a radius. We can see this because the line, which is being given by 11.2, extends from the center of the circle to the edge of the circle. It is not a line which extends from one side of the circle to the other. That would have been our diameter. Instead, they give us the radius. So we can substitute the value for the radius into our volume formula. So we'll have 4 over 3 times pi times 11.2, and that is cubed. Now we can type all of that into our calculator, and you should see that there are many decimal places. So for our final answer, we are going to round off to 2 decimal places, and therefore our final answer will be approximately 5884.95. And for this example, they didn't tell us what the units were. They didn't tell us if we were dealing in centimeters or inches or meters, so we are going to say units. And since we are still dealing with volume, which is a 3-dimensional element, it is units cubed. And that is a final answer for question number 10.